Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Alright, so for today class, we're going to do LO 1.1b, which we want to determine the dimension of derived quantities. Okay, so before we go to this subtopic 1.1b, okay, we need to do some revision on what you should learn in lecture. So in lecture, you will do this part. So I'm just going to go through this first before we go through 1.1b in details. So what you're going to learn is about physical quantity, and it is defined as a quantity which can be measured. Okay, so means that the quantity is measurable. It can be categorized into two types. Okay, so physical quantities have two types, which is the basic and the derived quantities. So the basic is such as a length, time, mass, etc. Okay, so derived quantities such as velocity, acceleration, force, and etc. Okay, so for this, for the basic quantity, okay, means we can measure it directly using the device or the machine. Okay, so such as length, we can measure the length using ruler. Okay, so we can measure it directly, and time we can use stopwatch. Okay, and for mass we can measure it also directly using the weighing scale. But for this quantity here, it is derived because we cannot measure it directly. We need to use equation to find the velocity. Okay, which is for velocity, the equation is the change in displacement over time. Right, so that's a bit of introduction for physical quantities. So first we will go through dimension. Okay, so dimension is a new topic for all of you, I guess. So what is dimension? Dimension is a technique or method which the physical quantity can be expressed in terms of combination of basic quantities. So it is a method used by physicists, okay, to express a quantity in terms of combination of basic quantities such as velocity. So velocity is a derived quantity. So we want to express it in terms of the basic quantity, which is length, time, and mass. So it is velocity is actually displacement over time. So displacement is a basic quantity, which is length, and time is also a basic quantity. So this one is what dimension does. Okay, so table shows the dimension of basic quantities. So these are all the basic quantities we have: mass, length, time, electric current, temperature, amount of substance, and luminous intensity. Okay, so for this one, why we have a square bracket here? Why we have the square bracket is because it want to show you that the dimension of mass, how you read this is that the dimension of mass, okay, the square bracket means we want to find the dimension of mass. So the dimension of mass is m. Okay, the dimension of mass is m. So for another way of writing this, which is very simple, is using the symbol for mass, which is the dimension for mass, which is we denoted as M, is M. Okay, so you can either write it in terms of the word or the symbol for mass. Okay, so the square bracket here meaning that we want to find the dimension of mass. So let's say we put the square bracket around the symbol L. Okay, so meaning we want to find the dimension of length. The dimension of length is denoted as symbol L. So L is the dimension for length, and so on. For time, the dimension for time is the capital T, and for current is I. Okay, so the unit for this, okay, you need to know the unit, you need to remember the unit, as this is going to be very important in writing the final answer. Okay, so for this one, okay, we usually use up until this one. Okay, usually. Okay, for the temperature, amount of substance, and luminous intensity, you're gonna use it more on semester 2. Okay, so moving forward, okay, we're gonna continue to the next subtopic.